The basic meaning to this kind of learning is understanding and remembering. Any sustained effort to learn about any topic, subject, or activity will inevitably require students to acquire a basic understanding of a particular data, concepts, relationships, and perspectives, as well as the ability to recall this knowledge in the future. Nearly all kinds of significant learning will be based on, and hence will require the students to have, an in-depth understanding of some subject matter, and that is why it has been labeled here as foundational knowledge. In CPRE 185, we make extensive use of mnemonics to facilitate long-term recall of the material. The abstract nature of computer engineering makes the course particularly suitable for this. Therefore, instead of having to recall abstract foundational knowledge, the student recall images, sights, and sounds associated with the learning of that particular knowledge. For example, when teaching about function calls, we use the theme how Italian mafia used to rule Chicago streets during the Great Depression. The main function, which is the entry point of an engineering design, becomes Al Capone, the big boss. The problem itself becomes the mafia victim. Like a mafia separates or sorts money from people, the system itself sorts knowledge from the data. When the boss desires the job get done, he will use one of his right-hand people, who will each have capos, who will have each henchman, who will have direct contact with the data. Every level of hierarchy report to the upper boss upon successful completion of a mission with a return call when their part of the job is complete. Functions work just in the similar fashion. Even at the end of a 15-week course, students will immediately remember the functional hierarchy of a computational system only when the Capone's name is mentioned. Instructors frequently talk about wanting their students to learn how to use knowledge in some way. However, knowledge can be used in multiple ways, which is why this category of significant learning has multiple meanings. As used here, application or foundational knowledge includes developing particular skills, learning how to manage complex projects, and developing the ability to engage in various kinds of learning. CPRE 185 has distinct applied components where students put the fresh knowledge into immediate use. Instead of asking every student to fit into one particular mold of how the knowledge should be applied, we have allowed flexibility in the system to let the student decide which form of applying the knowledge is most meaningful to them and leads to efficient learning. One of these components is the turn project, where students are allowed to define their own topics instead of being asked to apply a single topic or select from a limited subset. Another such component is the design of the assignments. Most questions have more than one correct answer, as well as more than one incorrect answer, where the concept of best answer is allowed to float according to the context the student chooses to explore. These practices allow the students to gain project management insight and critical thinking capability in addition to the skills they are expected to learn from this course. This is when students learn how to connect and relate various concepts, ideas, thoughts, and knowledge to each other. Many educators have emphasized three major kinds of such connections. 1. Interdisciplinary learning. 2. Learning communities. And finally, 3. Connecting academic work with other areas of life. Interdisciplinary learning spontaneously occurs in CPRE 185 due to the way the class is designed. 2 real-life case studies from past semesters. A student who also happens to be a musician uses the PsyCalc platform to build a training digital piano, whereas another student who is interested in cybersecurity will use the exact same platform to build a multiplayer application. The piano project will then use the other student's multiplayer project to build a multiplayer piano, where an instructor can remotely train a music student. In the context of all this, both students are using C++ to solve an interdisciplinary set of problems that are useful and meaningful to them in an individual level. The act of connecting these modules together, in terms of different student projects working together towards the solution of a bigger problem, helps build learning communities where the students with otherwise diverse interests get together to share a common learning goal. This kind of significant learning addresses the important relationship and interactions we all have with ourselves as well as others. When we learn how to fulfill these relationships in positive ways and how to honor them and advance them, we learn something very important. College students frequently report that learning about themselves and about others is among the most significant experience they have during the college. It's also clear that this is something more than and very different from acquiring information about people out there. And the difference lies in the existence of a real relationship. Students often arrive at a university with a preconceived notions about their own capabilities, which are seldom accurate. This is a time of great confusion for them trying to decide the directions in which to establish their career path. A significant majority of CPRE 185 students are undeclared majors who have come to sample engineering before they commit to it. Faculty observations indicate that a high percentage of these students are indeed engineering material, whereas a minority have been pushed into the discipline for various reasons such as peer or parental pressure, financial aspirations, etc. The course is responsible to point these students in the right direction, and this is only possible if they are allowed to sample the true taste of engineering life with tacit engineering knowledge as opposed to a canned version of engineering skills. Due to the motivation CPRE 185 provides towards engineering, we observe a very high retention rate, that is, ratio of undeclared majors who are in between two diverse disciplines, such as engineering versus veterinary medicine, choose engineering. What instructors want is for their students to care more deeply about something, that is, to value something differently. As a result of their learning experiences, students might care more or differently about the following: the phenomena studies, the ideas studied, their own self, the others they encounter in the class or the study, as well as the process of learning itself. One other practice that we follow from the beginning of the course is to give this clear message to the students, that the exam questions in this course will not be canned parts of the lecture material. In other words, attending the lectures and reading the materials alone will not be enough for success. They will have to teach themselves the capability to learn a skill on their own, if that is what it will take to solve a particular problem. Most of the assignments in the class are designed such that the students are required to learn a new skill, however small it may be, outside the class environment, and to be able to proceed with the question and actually use the knowledge that was imparted in the class. While it's typical most students will initially resist the idea that the exam questions may actually come from unpredictable sources, once they see the value of doing this, faculty observation states that they adapt to the idea very quickly, and in fact, they start welcoming it on other classes. The sixth general kind of significant learning is that of helping students learn how to learn. Similar to valuing and thinking, this goal holds out the promise of being particularly effective in enabling other kinds of learning. We help people learn how to learn during the course and after the course is over. Learners will be capable of continuing their learning for the rest of their lives, which is a truly attractive prospect. Learning how to be a better student, how to construct new knowledge in different domains of inquiry, learning how to be a self-directing learner. CPRE 185 is designed to convey the message that engineering is a journey, not a destination. The aspiring engineer will never stop learning, not until the end of his or her career. This is a bare necessity to adapt to the ever-changing nature of challenges in science and technology workforce. There's a large and preconceived notion that an engineer has to suffer 4 years of intense training, which stops at the diploma, which then becomes a money-making machine for the rest of their lives. This cannot be farther from truth. In the interest of serving this goal, memorization is one of the first bad practices we have removed from CPRE 185. All examinations are given open book and open notes type, and all assignments encourage literature review. The students are pushed to learn where to find accurate information rather than memorize it in its form. In the current state of affairs in technology, memorizing is not sustainable. It's simply impossible to learn everything there is about a discipline that in fact never stops growing, let alone do this in a finite amount of time.